Okay guys, welcome back to day 3. We are going to start with a review question. If you know how to fill this out, feel free to move to the next one. If you missed this in the last lesson, both of these, the filling out and the question below are on the test. So this is a normal distribution where most of your data is going to be in the large part of the curve. 100% of your data should fall beneath the curve. So the mean is right in the middle. And then we're going to do 3 standard deviations above and below. And it says that my standard deviations go by 5. So I'm going to go 3 standard deviations above while I count by 5s. And 3 standard deviations below. Okay, then using that, I'm going to figure out what percentage is greater than 105. Well, we were given percentages in our last meeting. This percentage was 13.5, and this one was 2.35, and this was, I believe it was 0.15. So it's going to be a total of 16%. What percentage is between 90 and 95? That is here. And again, that particular percentage is 13.5. Okay, so if you don't recognize those percentages, they show up in the slides coming up as well, and I believe they're given on the test. So we're going to talk about something called a Z-score. So Z-scores kind of help you decide how many standard deviations from the mean a score actually is if it's not perfect. So like we've got these 4 runners who ran different races, and they have different times and different places, but we don't know how well these racers did. Steve might have been 64th in a race with 67 people, so he was close to the end, whereas Sarah ran a race of 200,000 people and she came in 127. That's pretty good. So how do you know? How do you know how well they did in comparison to others? So let's take a peek as to how to do this. Here we have a little bit more information. We're given the weather conditions. I remember running a race when it was 99 degrees out. I thought I was going to die. There's lots of different conditions that would attribute to the race time or place. This also kind of helps. The standard deviation. Sarah's standard deviation was 73 minutes. That's a very large standard deviation versus Lindsay's race, 21 minutes. That means that whatever the mean race time was, lots of people were close to that race time. Whereas Sarah's race, it was kind of all over the board. So that helps a little bit. What we're going to find out that's going to help us compare is something called a Z-score. Now, this looks a little foreign. Z stands for Z-score. You just have to remember that X is your score. Actually, let's not say score. Let's say X is your data. So it could be your height, your race time, your, plant height, whatever you're looking at. This mu is a fancy Greek letter for the mean, and the red is the standard deviation. Okay, so how do we do this? You grab a calculator and you take your data point. So Steve's data point is 412 minutes, so we'll write 412. Then we subtract the mean, which is 475, and we divide by the standard deviation. I'm just looking at his time, the mean, standard deviation. This is not going to give me a perfect standard deviation. Before in the warm-up, we had 1, 2, and 3 standard deviations. This is going to give us a decimal place, but it's going to tell us how many standard deviations from the mean Steve is going to be, and how many standard deviations Lindsay's going to be. So Lindsay was 439. You subtract the mean, divide by standard deviation. I'm going to go ahead and do these, and we'll be able to compare the runners. So I found the Z-scores for all of these. Notice they're all negative, which means that if this was the mean for all of these races, the negative Z-scores show up to the left. The people who are all the way over here, the furthest from the mean in terms of negative standard deviations, they were the fastest. And the ones here would be the slowest. Just because this is in terms of time. So the smallest numbers would be the fastest and the largest numbers would be the slowest. It took them the longest to finish the race. So the person that is the furthest away from the mean would be this person, who's almost 3 standard deviations away from the mean, which would be a super fast time. So this is a Z-score. This is what we're studying for this quick unit. Every normal distribution can be turned into a standard normal distribution using Z-scores. The Z-score has a mean of 0 and standard deviation of 1, which means that basically a Z-score can't be bigger than 1 or smaller than smaller than -1. It helps us compare data, and it tells us how many standard deviations the score is away from the mean. Okay, so this is the curve that I was talking about where we've already figured out the areas under the curves. We only know 1, 2, and 3 standard deviations away, but what we're trying to figure out is what if a score lands here? That's going to be 0.5 standard deviations away. That's called a Z-score, something that's not perfect 1, 2, or 3. And then because we don't know exactly how much area this is versus the whole 34, we're going to use our calculator to be able to calculate. That's coming up. Okay, so let's find some Z-scores. We have a set of data that's normally distributed with a mean of 77 and a standard deviation of 4.2. Find the Z-score for the data value of 86. 86 minus the mean divided by 4.2. I get 2.14. So 2.14 standard deviations above the mean. Find a set of data that is normally distributed with a mean of 123, standard deviations of 8. Find the Z-score for the data of 118. I want you to try this, stop the video, and then check. So I have a Z-score of -6.25. Again, on a normal distribution where this is your mean, 2.14 would show up somewhere over here. 2.14 standard deviations above the mean, whereas -6.25 or 0.625 might show up there. A little closer to the mean, but to the left. So we're going to figure out because these are different classes, where did this person, Julia, do better? So we're going to rank them best to worst. So go ahead, take a second, figure out all her Z-scores, and then we'll come back. Okay, these are my Z-scores that I get for Miss Julia. Julia looks like she's a pretty good student. All of her Z-scores are positive, which means she did better than most of the class on most of her tests. Now, the Z-score that is the biggest, the highest above the mean, is the one that she did the best on. So I would say that English was her best test because that is the highest Z-score. It's the highest above the mean. Then Spanish would be the 2.26, and then I would put math as her third best test score, and then geography as her next, and her last was bio. Though she did better than not everyone, though she did better than the mean, she just barely got higher than the mean. Okay. And then remember, if you have a Z-score that's positive, 1.75 means that it's almost 2 standard deviations, 1.75 standard deviations to the right or above, and negative means it's to the left or below. And the purpose of Z-scores is to enable us to compare values from different data sets with different means and different standard deviations. Go ahead and move on to the next video, and I'll show you how to put all of these into your calculator.